Hey guys, welcome to my channel. Today we have an amazing problem for you guys where it's called find center of a star graph. So very good problem. So let's go ahead and read the problem statement, right? So it says there is an undirected star graph consisting of n nodes labeled from 1 to n, right? A star graph is a graph where there is one center, right? Okay. And exactly n minus 1 edges, right? That connect the center node with every other node. Okay, so we are given a 2D integer array edges, right? Each edge, right, represents, so every index in the edges array, right, represents an edge, right, which is, the edge between nodes u and v, right, which is what we have two coordinates, right, u, v, right, 2.2 data, right. Return the center of the star graph, right? Okay, so we're given a star graph, right, labeled from 1 to n. It has n nodes, right? And then there's one center node, right? And then there's exactly only n minus 1 edges, right? That connects the center node to every other node, right? Okay. So for all the edges, right, that means that the center node will appear in all of the different edges, right? Because there's only n minus 1 edges, right? And the center node connects to all the different nodes, right? So very important. Make sure you keep that in mind, right? This whole problem, right? So everything makes sense at the end, right? So we're given this thing right here as graph, okay? And we can see the center node is 2, right? Because, it's the only node that's literally at the center, right? That connects, right, to all the different nodes, right? You see it has exactly n minus 1 edges, right? So you see we have 4 nodes, 1, 2, 3, 4, right? And then we have 3 edges connecting to 2, right? So, all right, so that's what we return to, okay? So this problem is very interesting, right? Very interesting. So how can we solve it, guys, right? This is a graph problem, right? It literally has graph in the name, right? So what I'm thinking here, right? So we're given edges, right? We've done other graph problems that, deals with this exact sort of setup, right? We know how to represent graphs, right, in memory, right, using different approaches, right? I think did tutorial on that before, so we could, use, I believe, at this problem, right, adjacency list, right, to represent the graph, right? Pretty easily, right? We could build that, so that we're gonna have a map, right? And then the map, we have a key. The key is gonna be the node, right? And then the value is gonna be all of its neighbors, right? That's how we do it. It's a list, right? And then that way, guys, right? For every node, we could store all of its neighbors, right? And then once we have that piece of data, right? So let's say once we build it, right? Let's say we put the first edge. We have 1, 2, right? So 1. So it will look like that, right? Just a quick recap, right? So we put 1, 1 would, have 2 as its neighbor, right? And as well, 2 will also have 3, right? Well, I mean, 1 at its neighbor, right? That would be one edge, right? That's one connection made, right? And then we will have that here. And then we continue building it, guys, right? And we go to the next one, we add 3, because that's one of the neighbors, right? That's what we have here, right? It's one of that to show that relationship, right? And then 3, we will put entry for 3 as well, right? And also we'll have 2 at the neighbor, right? And then we went to 4, we put 4, and then we'll have 2 at its neighbors, right? And then 2 would have 4 as the one of its neighbors, right? And then after we do that, right, we build our graph, right? We just loop through all the nodes, right? And we find a node that has exactly n minus 1, right? Edges, right? And minus 1 neighbors, right? Which tells us that that's the star node, right? Okay. Star node has a edge with every single node, right? So, which is important, guys, right? So that's how we would get that, right? But we could do a little bit better, right? We don't even need to store the actual numbers themselves, right? Because there's no advantage of doing that, right? So we could simply, I'm thinking, use a counter, right? Right? If you use a counter every time, we just do a +1 every time we have a new connection, right? A new edge, right? new neighbor, right? Which is your +1. So we could remove that and build our thing that way, right? So our first one, edge one, that was only one edge, right? It's pointing only to one, right? And once you get here, so two, we have one as well, right? And then we update the same thing, right? We put one, put three, right? And then we increment the count as two as well, right? That's the second one, right? And then just like that, we would have our final answer here, right? And then we do the same thing, we loop through, we find exactly a node with the value of 3 minus 1, n minus 1 edges, right? And which is exactly what we have here, which is 3, guys, right? So easy peasy, right? So I think that's the approach we could go with, right? I think that's one of the best way of going about it, right? So let's quickly go ahead and do that. So we have integer. Okay. Think like that, we'll be able to solve it easily. Okay, so what we're gonna do after that, right? We're going to pretty much loop through the edges thing, right? It's u, right? We get that value, we get v. And then we just put the relationship, right? It's u, and we do a map that get or default. I'll put u as well and put 0 plus 1. It looks good. We've built that relationship, right? We've got the data that we need. What's left for us to do now is to look through and find the exact on the center node, right? So what we're going to do, we're just going to do a for loop for every node, right? And the thing that we have, tripping. We do a check here, guys, right? If the node has exactly n minus 1, right? If we could simply return that node, right? If not, if we never encounter that, then we just return -1, right? To signify that we haven't found that, right? We got this, press run code. Looks good to me. Let's press submit. Awesome, guy. Pass all the test cases, guys, right? So this is a very simple solution, right? But we could do a little bit better, right? One of the solutions that I found by just going to the discussion section, right? So it's always good to go to the discussion section, right? I think my solution will be a decent solution for at an interview setting, right? This will be good enough, right? But let's see what them smart guys are doing there, man. Guys with, big brains. Let's see what they're doing there, right? So it looks like they can do it in one line, guys, right? Let's see what's going on, right? So what they're doing, right? This is very, very clever, by the way, right? It says that a center node must appear in every edge, right? So since we know that fact, remember I was saying that earlier, right? Since we know that, right? We know that, in the first edge, right, that we're given, right, we'll be able to find which we can determine which one of those two numbers, right, in the first edge that we see, right, that is the star node or not, right? We do that check, right? We check the first number, right? Is the first number in the array that we see, right? Is that the one that we do a check, right? Is that the one that's the star node? We do that check by checking the next one, right? Is this the node that I'm looking at, right? Is it in the next one? Is it in the first index, or is it at the other index, right? So if the first one is the first u, right, it's part of the next edge, right? Then we know that it's going to be that node, right? Otherwise, it must be the other number that it forms the edge with, right? We know it has to be one of the two because of the fact that the star node is going to be part of every single edge, right? And that's how then we would come up with just a one liner here, right? This is very, very clever, by the way. I didn't read the problem statement close enough to really catch a center node must appear in every edge, right? That's very, very clever, which is one of the things that you need to do every study, right? Read the problem statement carefully and make sure you pay attention to every little details that are given to you, right? So yeah, this is a very good problem, right? We could see this at play, right? We check, is one part of this edge? No, it's not. Then it must be this node. That's the starter, right? That's essentially what the boys are doing here, right? Again here, right? We check, is this node part of the second? Oh, it is. Then that's the node that's starter, right? So it works, right? It's a very, very clever way of doing it, right? So I want to thank you guys for taking the time to watch the video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.